Guess hope everyone is doing great. So our discussion today is going to be one of the factorization techniques that we mentioned in our previous video, and that is the concept of using special products. Now for this we're just going to mention it, and then we're going to look at a second technique, of course, which needs us to elaborate more by trying to figure out how we can be able to do find factors of a polynomial through substitution. Now in this case, for special products, I'm just going to give two examples. And last time we had said that if we have a plus b, and then this one is multiplied by a minus b, which has two specific set of terms, so we're trying to find the product. This is going to give us a cube. No, this is going to give us a squared. And then for subtraction, this is going to give us a squared b minus b squared. And we said from this, for us to do this multiplication, the reverse process of this multiplication is known as factoring. So this is one of the techniques that we can use to find the specific factors of this polynomial by trying to do the reverse of this process. Now in this case, if we have been given a product which is a special product of these polynomials, then we can outrightly identify the specific factors that are contained in that case. Now for instance, if I have this is a squared minus b squared, sometimes later we are going to see that this is a difference of squares. In some of our discussions, we're going to regard that one as a difference of squares. Now if I give another example of a polynomial, which is 9x to the power 4, and then minus 16x to the power 2. We try to look at this for the coefficients and these particular degrees of polynomials for x. Then we're going to see that this is a product of specific factors, which is basically a square and this one, and their respective coefficients as well as squares. So therefore, this is analogous to this, and we can be able to find a representation for that one by just finding its factors, just like in the case of the first one. So for that case, we're going to see that for the two factors, for the first set of a factor or expression, it's going to give us 3x squared. Just like this, the first one is going to be plus an addition, and then the second one is going to be a difference of those two respective set of factors. So it's going to be a 3 plus a square of 3x, and then for this one it's going to be an addition. So the square for this one is 4x, and then the second factor is going to be a difference for this, which is 3x squared minus 4x. So from this special type of products, we can be able to identify directly the factors which are contained in there. So next we're going to look at factoring by substitution, which is going to form our last bit of our discussion on factorization of polynomials. So this one also I'm going to give it by using an example, but we're going to explain more on basically how that process or procedure can be done. Now for complex expressions, we're going to see that they're going to be replaced with a single variable, and the resulting, of course, polynomials factored out first. So in case maybe we have a complex polynomial, rather higher order polynomial like that one, we're going to have a 6w squared and then minus 16. So in order for us to simplify such kind of a polynomial, we're going to have to use a single variable to represent one of the part of this particular polynomial by saying let w squared represent x, a number x. Therefore, we are going to write this specific polynomial, and then they say this is x squared minus 6x minus 16. So therefore, this is going to give a set of a simpler a polynomial which we are going to solve using the normal method of using ax squared plus bx plus c. So therefore, finding the product of AC, this is going to give us negative 16. And then this should be a sum of the factors of b. And we're going to look at this and find out what are some of these factors. So if you try to look at 6, we're going to have a difference. This is minus 8 plus 2 is going to give us 6. So we can write this specific expression by first writing that one as x squared minus 8x plus 2x minus 16, and then we're going to just have this one grouped and then find out the greatest common factor, which is going to be x into x minus 8 plus 2 into x minus 8. Therefore, this is going to be x plus 2 x minus 8 as the factors of that polynomial. But remember, our inclusion of x from this specific point was for simplification purposes. So therefore, we're going to return our x and say that this is going to be w squared plus 2 into w minus 8 as the respective. So this was w, okay, x represents w squared, so that is w squared minus 8. So this is one of the ways in which we're going to, of course, apply this concept of substitution by trying to find, of course, express a complex polynomial with the, by using a single variable and the resulting polynomial factored out using the previous discussions or the factors that we had already discussed in one of our videos on still the concept of factorization. So I hope that we are going to apply these ones appropriately as we come across them in different areas in mathematics and sciences. And this is going to form our last bit. Of course, there are other areas that we're going to see, of course, like factorization using a rational zero theorem and others, which are going to come later. So that is it for now, guys. Bye. God bless you.